In this episode series, we'll be looking at Ansible, which is an easy-to-use configuration management and orchestration tool. My goal for this series is to show you what Ansible is, how it works, and the steps to get you going on your own. I split this episode series into 4 parts, mainly because I wanted to give you a crash course on what configuration management is, along with how Ansible fits into that picture. In this episode, part 1, we will look at a high-level overview of what Ansible is, how it works, and what you might want to use it for via some example use case scenarios. I'm mostly just going to show you what Ansible is via diagrams in this episode, along with some external reference links. No command line bits just yet. We're also going to look at configuration management in general, and how this is an improvement over doing things manually, in the hopes that this will give Ansible some context. In part 2, we're going to set up a bunch of virtual machines using Vagrant. We'll work through installing Ansible from scratch, how it operates at the command line, what the configuration files look like, and how communication works between nodes. Then in part 3, we'll look at using Ansible for configuration management tasks by taking generic virtual machines from our Vagrant environment and turning them into a web cluster using HAProxy and some Nginx web servers. Finally, in part 4, we'll use Ansible to do a zero downtime rolling software deployment across a cluster of web nodes. The idea is that we can deploy software updates across a fleet of machines without any downtime by using Ansible to orchestrate the various tasks for us. This comes in handy for continuous deployment workflows. Throughout each of these episodes, I will give you all the code and the commands used in the hopes that you'll duplicate my results, as I think this is a great way of learning. So now that you have a general idea of what this series is about, let's jump into part 1. I thought it might make sense to give you a brief overview of my take on the problem Ansible is trying to solve. Imagine for a minute that you have 2 machines. The one on the left could be your laptop, desktop, or even a server that you have access to. We'll call this the management node. The one on the right is a fresh Ubuntu virtual machine that we've just installed and booted. In reality, this could be a bare metal physical box or even a cloud instance. Let's say we wanted to turn this freshly installed Ubuntu machine into a web server. Say, for example, that we're running Apache hosting a website, a Rails app, or something similar. How would you go about doing that? Well, we could do this manually by SSHing into the machine, using the IP address 10.0.15.21, and running the commands to install your application stack, editing the configuration files by hand, and manually copying over our application code. Once you're all done, you disconnect and the machine is configured and working. Granted, this is a pretty common practice, but this is also pretty much manual work, and even if these steps are documented somewhere, each of these machines is generally its own little snowflake depending on how it was installed. This manual work can quickly compound if you need to do this across tens or even hundreds of machines. So it can be a real pain when one of these machines dies, because we're not really sure how exactly it was created, or how we go about recreating it quickly. Don't get me wrong, I've installed many hundreds of machines, so I know this issue well, and it's extremely unpleasant when something important dies and you're not really sure how to recreate it quickly. In that, you have a general idea of what was on there, but you engage in the exact same type of manual work that created this mess in the first place, potentially wasting many hours of your time in this drop work type task. Constantly installing packages, dependencies, checking to see if it works, installing more packages, and tweaking things manually until the service is finally restored. This turns into a vicious cycle, and we just recreated the exact problem scenario that caused this mess in the first place. There has to be a better way, right? Well, this is where configuration management tools come in. At a basic level, these are tools designed to automate away much of this manual work, saving you time, reducing stress, and generally improving the process of creating machines in a timely manner. So let's chat about Ansible. Ansible is an open source tool, mainly used on Unix-like machines, which is directly targeted at solving this type of manual work problem. Let's start our example over again and have a look at how we'd solve this problem using Ansible. We start with 2 machines again. The one on the left could be your laptop, desktop, or server, but this time we'll call it the Ansible management node, because this is where we're going to install the Ansible software. The one on the right is our freshly installed Ubuntu machine. And this could be anywhere from your local machine running a VM, a physical box, or even a cloud instance. Once Ansible is installed on the management node, you will typically need 2 configuration files, something called a host inventory and the other a playbook. The host inventory is basically just a listing of host names or IP addresses for machines that you want to manage, and how they should be grouped together. In the example here, our Ubuntu box has the address 10.0.15.21, so we'll just add this address to our host inventory, likely under the web group since we want this machine to be a web server. Actually, let me just show you an example of what the host inventory looks like, since this will likely make much more sense. So the host inventory INI file is basically just a listing of hosts that you want to manage with Ansible, and you can also group them together under arbitrary headings. You can use these brackets to create a group, then put the group name inside. In this case, we have a load balancer group, and it has 3 hosts assigned to it. For hosts that you want to manage with Ansible, you can use their fully qualified host names, short host names, or IP addresses. You can see down here we have the web servers group from the diagrams, and we've added our Ubuntu virtual machine's IP address used from the diagrams. You can also call these groups anything you want. Let's change the name from web server to just web. I should mention that you don't need to know too much about this right now, as we're going to cover this heavily in the other episode parts. It's just important to know that these configuration files exist. Playbooks are configuration files that outline tasks that should be performed against hosts in our host inventory. In our example today, we're going to be setting up a web server on our freshly installed Ubuntu box. So we'd likely want to install Apache or Nginx, update the web server configuration file, deploy our application content, and restart the server, etc. Basically, all of the tasks that we would have done manually, just documented in a configuration file called a playbook, so that Ansible knows what to do. Playbooks allow you to define each of these steps in a simple and quick to understand format that pretty much anyone not familiar with Ansible can read and understand. Let's quickly have a look at an example web server playbook. The configuration format is called YAML, but you don't need to really understand this to work with Ansible, as it's pretty straightforward. So here we have defined our host group which we want to run this playbook against. This should look familiar from our host inventory. Next, we have the sudo line here which will allow Ansible to connect as a non-root user, and then sudo to root to do things like installing packages, deploying configuration files, and restarting services. Next, we have a series of tasks that we want to run against each host in the host inventory web group. You can see here that we want to install Nginx, update the configuration file, and deploy our website code via git pull from version control. And finally, we want to make sure Nginx is started. This pretty closely follows what you would do manually in real life. Again, don't worry about understanding all of this right now, as we're going to look at live examples throughout this episode series. I should also mention that in our example today, we're going to be mainly looking at using playbooks. These are configuration files that outline tasks that should be run. But you can also run Ansible in an ad hoc mode, basically using it as a parallel command execution engine across a fleet of machines. We'll look at this heavily in parts 2, 3, and 4 of this episode series, but this ad hoc mode can be thought of as a smart parallel SSH engine. At least that's what I think of it as, just with a lot more cool functionality built in. So now that you have a basic idea of what the prerequisites are for Ansible, those being that you have to install Ansible onto a management node, define a host inventory file, and have some playbooks defined. Let's have a look at how we'd turn our Ubuntu virtual machine into a web server using Ansible. You run Ansible playbook on the management node, it looks through the playbook that we've defined as a command line argument, and Ansible notices that we've targeted nodes in the web group. Ansible then reads in the host inventory file to find nodes associated with that web group. At this point, Ansible is ready to get to work. So we'll remotely connect via SSH to the defined machines. Typically, you'll want to have some type of SSH trust established via a pre-shared key, so that you don't always have to enter the password all the time. Ansible will then start to step through the playbook tasks, one at a time, going through them sequentially from top to bottom, just like you would have done if you logged in manually. So it installs the packages, updates the configuration file, deploys our website code via Git, and finally starts our web server. When Ansible is happy that everything has worked as expected, you'll get a little status report saying that everything is okay. So that is basically the default Ansible workflow in a nutshell, but you'll soon notice that Ansible is a pretty flexible tool, and there are exceptions to pretty much everything I've shown you so far. For example, the host inventory can actually be a database if you have thousands of hosts. And you don't always need playbooks, you can also use ad hoc commands. You can swap out SSH for a queue-type system, say for example if performance is an issue with the number of hosts that you want to manage. But for these examples today, I thought I'd just show you what I think is the default mode of operation for when people start playing around with Ansible. So you might be wondering how Ansible is different from other configuration management tools like Puppet and Chef, for example. So I thought it might be useful to mention a couple items before we move on to more complex examples. Probably the most glaring difference is that Ansible pushes the configuration out to the managed machines via SSH. Ansible only requires that you install the Ansible software on the management node, and that the remote machine is running SSH and has Python installed, which every major distribution today has by default. So there's no remote agents that you need to install, and everything is done via SSH from the management node. This makes getting going with Ansible very easy, and the upgrades are a snap, because you don't actually have to update any remote agents. It's all done on the management node. The Ansible documentation is absolutely fantastic, and you can read the manual pages and quickly understand how Ansible functions, and I honestly can't say enough good things about them. You'll often hear the term batteries included when reading about Ansible. That is because there's over 250 helper modules or functions included with Ansible. These that allow you to construct playbooks and ad hoc commands to smartly add users, install SSH keys, tweak permissions, deploy code, install packages, and even interact with cloud providers for things like launching instances or modifying load balancers. Each module has a dedicated page on the Ansible documentation site, along with detailed examples, and I found this to be a major bonus when working with Ansible. I should mention that even though Ansible is using SSH to connect to these remote machines, your playbooks and ad hoc commands almost always use these 250 plus modules to smartly do things. I guess what I'm trying to say is that Ansible is not simply running remote commands like a shell script would do for automating package installs, adding users, etc. There's tons of logic built into these modules, and I encourage you to check out the manual pages just to get a sense of what's actually being done. One of the biggest pros to using Ansible is that since playbooks are basically configuration files, you don't need to be an experienced configuration management expert. The bar is set pretty low to get going. I think this is the biggest reason Ansible is quickly becoming popular, and that you're not really writing code, you're just working with configuration files like we typically all do. Ansible is also great for both ops and dev because you're not actually giving out root. Ansible is just using SSH to log into remote machines, so there's a clear separation of duties if needed based on what account Ansible is using. One added bonus of using any type of configuration management tool, including Ansible, is that these configuration playbooks are self-documenting. I guess what I mean is that you have a clear picture of how these machines are made and how to remake them if needed, because you have a step-by-step outline of the playbook. One last thing before we move on, there is a published Ansible best practices guide, and it's absolutely fantastic in the advice it offers. Things like how to lay out your files, using version control, naming, and how to keep things simple. It's probably the best published and put together advice I've seen out of all the popular configuration management software, by far. Okay, so let's crank out a couple more use case scenarios now that we have a basic understanding of what Ansible is. Once you have your playbooks figured out, you can use them as a starting point to launch any number of new machines, or turn existing machines into something that you want. Let's say, for example, that instead of just launching a single machine, maybe you need a bunch of extra capacity for your web tier, let's say for a holiday rush. So we launch a bunch of new generic virtual machines. And to manage these machines with Ansible, we just add them to our host inventory file like we did before, except this time we add all 6 machines. This might be where you want to use a database or some type of cloud module to pull new instances that you create, so that you don't have to do this manually if you have a pretty dynamic environment. Once all of these addresses are added into the host inventory, let's reuse our web playbook. Let's follow the same process as before. Run Ansible playbook on our management node that pulls in our web playbook, and the playbook references our updated host inventory. You can probably guess where this is going next. Again, Ansible connects out to each of these machines in parallel through a SSH trust. From there, it starts to run our defined tasks from the playbook. Things like installing the web server, deploying our configuration file, our code, and then starting the service, etc. Finally, each of these tasks complete, and we have our machines installed and ready to use, along with the summary from Ansible of how everything went. So we can just reuse our previous playbook where we deployed one machine and use that same thing to deploy an entire set of new machines. The limit of how many machines you can talk to via SSH is really based off your management node's resources, things like bandwidth and CPU. There are real-world cases of where Ansible manages thousands of nodes. People like Twitter and the Fedora project use Ansible. If you're looking for a little more details about how Twitter uses Ansible, check out this YouTube video. And I found it worth a watch because I always find it interesting to see how other people are using these tools. There's also a pretty decent slide deck about how the Fedora project uses Ansible too. And the Fedora project actually publishes their host inventory and their playbooks, which are an absolutely amazing resource for seeing how large projects are implementing Ansible at scale. One thing that I forgot to mention about Ansible is that once you run these commands to configure a machine, Ansible stops caring about them. It's not ever going to check them again unless you tell it to. And this is different from other configuration management tools, which typically have an agent that sits on each machine. You can configure Ansible to push changes out via cron or some type of continuous integration system, if you're interested in that though. Personally, I kind of like this type of system because you can force things out quickly via playbook run, rather than having machines eventually catch up. This also allows you to do one-off ad hoc type upgrades, say for example that you needed to patch OpenSSL, like during the Heartbleed drama. You just create a new playbook configuration that outlines your tasks. And I found these runs to be especially powerful for common sysadmin tasks. I think this kind of feeds nicely into our next and final example. Up until this point, we've used something called the web playbook, but let's switch gears for a minute and have a look at a different imaginary playbook. Remember that these are just configuration files that you can easily edit or create entirely new ones, since they're just files. So let's change that from the web playbook to something called the Zero Downtime Upgrade Playbook. We'll actually cover this in part 4 of this episode series. The idea for this example is that this is how many people are implementing continuous deployments across their infrastructure. You'll typically have a load balancer in front of all these web boxes. Then you'll use this type of tool to notify the load balancer that this machine should be taken out of the pool. Then we'll update the software and add it back to the pool. We're going to look at a live demo of this in part number 4, along with all the code, so that you can duplicate my results on your own. It's pretty neat that we can use Ansible to orchestrate this entire sequence of events for us. I should mention that Ansible has this concept of pre- and post-task handlers. So we will define our tasks as deploying a new software to a machine, but we'll have a pre-task that will notify the load balancer that will remove it from the available nodes, then we'll update our software, and finally, we'll have a post-task handler that will add it back to the pool of available machines. Let's just look at how this would work across a cluster of machines here. So let's run Ansible playbook again. This time it'll pull in our Zero Downtime Upgrade playbook. Then it'll pull in our host inventory. Again, you could use some type of database if you have a very dynamic environment. Finally, we use our SSH trust based on a pre-shared key to connect to each box, one after another, removing it from the load balancer, updating the software, and then re-adding it to the load balancer, then moving on to the next node. You'll notice here that we're doing this in sequence rather than in parallel, and this is an easy option to change in the playbook. I've actually done these type of tasks manually before, and it really sucks, because there's so many moving parts, and it's really easy to make mistakes. This is a major limiting factor to releasing software updates out into production, because it takes a long time, and you're fearful of breaking things. I actually found a really good article that talks about this, and I thought I would end the episode on it. The Guardian released a blog post recently about how they went from 25 manual deployments of their site per year to over 24,000 highly automated deployments using an in-house build continuous deployment tool. This is pretty much exactly the use case that I was talking about, although the Guardian is not using Ansible. Their struggle really rings a bell for what many people are going through. If you have time, I highly suggest reading their story, as I think it illustrates much of the thinking, rationale, and work that goes into deploying something like this. Okay, so that pretty much wraps up this episode, and I hope I whet your appetite for the types of problems that Ansible is able to solve. The remaining episode parts should be out shortly, sometime probably in the next week, so check back soon. Alright, that concludes this episode. Thanks for watching. If you would like to get notified about future episodes, please subscribe to my mailing list. You can do this by going to the Get Notified link in the header and entering your email address. Have questions, comments, or concerns about this episode? What about episode ideas? I'd love to hear your feedback, either good or bad. Shoot me an email, justin@sysadmincasts.com.